Hello everyone, today we are going to demonstrate how to do question number 3 from 2018 AP Chemistry Free Response questions. The first question wants us to write the electron configuration of the Fe+2 ion. Please notice that Fe+2 ion has 2 less electrons than Fe. So we just look through our periodic table and write out the electron configuration. To shorten the answer, we could also use the noble gas configuration. In this case, the closest noble gas is Ar, so we just write Ar and then write the rest 3d6. And you will receive 1 point for either write the 4 electron configuration or write the noble gas configuration. Since Fe+3 ion has 1 fewer electron than Fe+2 ion, it has less electron repulsion, which means it has a smaller radius. You will receive 1 point for the correct justification. The Coulomb's law is written on the screen. As you can see, if we have a smaller radius, we will have a stronger force. And if we have a larger charge, we will also have a stronger force. So the Fe+3 ion has a higher charge and also a smaller radius, so it has a stronger attraction with H2O. And you will receive 1 point for the correct explanation. For this question, we are writing the balanced equation for the half reaction for the oxidation. So oxidation means that we are losing an electron, and which means that the electron should be on the right side of the equation. And you will receive 1 point for the right equation. For this question, we need to convert the unit first. So we change milliliter into liter. And then we use liter times molarity to get the number of moles of MnO4-. And then we use the number of moles of MnO4- times the ratio of 5 to 1. Then we get the moles of Fe2+. After we get the number of moles of Fe2+, we use that to divide by the sample value to receive the molarity of the sample solution. And you will receive 1 point for the moles of Fe2+ and 1 point for the correct concentration of Fe2+. The 25 milliliter volumetric flask only has 1 mark at 25 milliliter. And you will receive 1 point for the correct explanation. In order to calculate the number of moles of Fe in the Fe2O3 produced, we need to use the mass of Fe2O3 produced, which is 7.531 grams, divided by the automatic mass of the molecule. We calculated the automatic mass of the molecule by adding each component of it, and we received that number from the periodic table. In this case is 159.7 gram. And then we need to times the ratio. So for every 1 mole of Fe2O3, we could produce 2 mole of Fe. That's why we times 2/1. And then the answer is 0.09431 mole of Fe. You will receive 1 point for the correct number of moles. We need to use our previous question's answer, the number of moles of Fe times by the automatic mass of Fe, to get the amount of Fe produced. And then we use the amount of Fe produced divided by the mass of Fe with interimpurity, and times by 100% to get the percent by mass of Fe in the original sample, which is 78.34%. And you will receive 1 point for the correct percentage? The answer is lower, because FeO has higher mass percent of oxygen than Fe2O3. The iron need to react with more oxygen to produce FeO. So there will be less iron left, which result the calculated mass percent lower than the actual mass percent. And you will receive 1 point for the correct explanation.